Miranda? Is that you? How was your weekend? Is it all right? Oh, okay. Did you have a good 4th? Yeah, you have to work? How about Luke? Where's Luke? Luke's not here today. All right, well, any questions on homework? You were supposed to do as much of that factoring. Yes, factoring homework. Anything off of that you'd like for me to discuss? 26. This one? That look like it? Okay. So I had a feeling there would be some questions. Specifically this one right here, I knew there would be an issue with. So let me put something down here first. Okay. All right, you see this problem here? That's not number 26, right? That's not number 26. But if this were the problem given to you, could we do this one? So let's run through that one first, and then you'll see where we're going to go with this one, all right? So for this one, we go through the procedure. Greatest common factor, there is no greatest common factor, right? So we count the number of terms. There's 3 terms. And because there's 3 terms, we're going to use the AC method, right? So we go like this. What number would go here? 5. Okay, so that's taking the 1 here, multiplying by 5, and then here we put 6, right? And that comes from this number here. We try and come up with 2 numbers that multiply to be this, but add up to be this, and after a little bit of thought, 5 and 1 are 1 and 5. All right? So far okay? All right, so now we rewrite this. This becomes, we leave the ends alone, and then we use these 2 numbers to rewrite the middle term. So this will become plus 1x and then plus 5x. And now we have 4 terms, so we do grouping and we split it right there, right? Then out of the first 2 terms, what can we factor out of the first 2 terms? X, we'll be left with x plus 1. And then kind of doing what we did last time, we played this game where we would put what we need here, x plus 1, and then we try and figure out what goes here to make this become this. So what would I need out there for that question mark if I wanted to make that turn into 5x plus 5? I need a 5, right? And since it's a positive 5, I'll put plus 5. And then now we're there, right? This is kind of the place we want to be with this. So since these match, we go ahead and write that down. And then in parentheses, we put the x plus 5, and we're done. All right, so that's how we would handle that problem had it been this, right? Now, this problem is different. So with this one, we did not do one of these in class, which is why I started class today with any questions. So I'm glad you asked this question. So the big difference here, you see over here we have x squared, right? And then the next term, it's x to the first power, and then there is no x term. So you can almost look at it like the powers of x are going down. Y'all agree? Okay. On this one, we have the same thing. X squared, we have x, and then the x is gone. But the y's are backwards. They're the reverse of that. So we don't have any y's. We have a single y, and then we have a y squared. So it's opposite of what the x's are doing, right? Yes? Yeah. Okay, so for this, we're going to do it the exact same way. We're going to create this chart, that little x thing. And now when we rewrite it, we leave the 2 ends alone. But what do you think is going to go in the middle here? Instead of this being 1x and 5x, in order to recreate this middle term, 6xy, what do you think we'll put here? So plus 1xy, right? That'll give us one of those, and then plus we use the 5 5xy. Does that make any sense? You see the difference there? It's the same procedure, except that you're trying to rewrite this, which has a y with it, instead of this one, which did not. Any questions? Y'all seem okay with it?
Do they both need xy or just one?
They both, because remember, the whole idea here is that we're not changing the problem. Okay, what we're doing is we're taking this problem and we're rewriting it. Maybe if you look at this one instead, all we did was we left the x squared alone, we left the 5 alone. The only difference was that we just came up with another way to write 6x, right? We said 6x is also 1x plus 5x. So we have to have x on both of these, so when we combine them, we get 6x. Here, same thing. We leave the two ends alone, but we're trying to rewrite 6xy. So we put 1xy plus 5xy. Those add up to be 6xy. Okay, so you need the xy on both. Now, 4 terms, you slash it, and now you do GCF again. So what would happen here? What can I pull out of these two? Again, an x, right? But this time, what are we left with? We pulled 1x here, so we're left with x. And then here, we pulled this x here, right? But we're left with a y, so plus y. So see the difference? This is x plus y. This was x plus 1. Now, we need that to do the same thing here, right? We need exactly the same, x plus y. We need it here. So the question is, what do we put out here so that when you distribute through, you get this? So what's missing? We need x to become 5xy. We need y to become 5y squared. 5y, right? So we need a positive 5y. And now you write down what matches. The x plus y is what matches. And then you write this plus this in another parentheses. Okay. So do you see that it's pretty much the same procedure except for this middle piece? And then when you do the grouping, you get something a little different than what we had in class. But basically, it's the same thing. Does that help resolve that for you?
Yeah, I guess what threw me off was when you had mentioned about descending order.
Yeah, okay. Exactly. When we have just x's in here, then you put it in descending order, right? But what if you have x's and y's? What you do is you put one of them in descending order, and then the other one has to be the opposite. So like if they gave you this problem, and let's just say that they had put like a squared on that y, we wouldn't be able to do the problem. Like we would be stuck. So good question. I was hoping that someone would ask that question. Any others? Were there any others like that appeared in the homework? I think that may have been the only one. 28. Okay, so 28. We can do 28. Luke, how was your weekend? It was all right. You have to think about it there. Excuse me. It was okay. It was okay. I did a lot of cleaning of my garage. It's hot. Which really means cleaning my wife's stuff up in the garage. I have 62 plastic containers in my garage that are all labeled. Yeah, all those things and a bunch of other stuff. Okay, here we go. So, all right, let's get going. Since y'all seem tired today, let me get y'all going. How about Jared? Jared, how was your weekend, Jared?
Pretty good.
Yeah?
A lot was fun.
Good? Yeah. Good. All right, so where do we start here? Ask to factor. So what do we do to begin this?
You do the greatest common factor.
Okay, and do we have one?
Yeah, I think it'd be 8x squared.
We have 8 here. We don't have 8 here, though.
Oh, true.
Right?
Okay.
So just x squared? Okay. And then when you do that, leave enough room for 3 terms here, right? Because we're starting with 3. So what would go here?
X squared.
X squared. And then here?
Minus 8x.
Good. Final.
And plus 2.
We didn't pull the 8 though,
Yeah.
right? So we just pulled the x squared,
Okay, so just a 16.
just the whole 16. There you go, right? And now, Laura, Kay? Laura? Did you have a good weekend, Laura?
Yeah, I did.
Okay, oh good. With the 3 terms that are in here, Laura, right? That forces us to use AC, right? Okay, so if we do that, can you tell me what goes here and here? I tell you what, let's do quiz grades today based on when I call on you. Now you have to get it like mostly right, okay? But if you get mostly right, then I'll give you 100 on a quiz, all right? Luke, I'm gonna have to put you back in the pile because you only told me how your weekend was, and Miranda. And you asked, you know what? And you asked me also. Okay, so what goes here and here? 8 and 16. So which one's, the top one is, remember the AC method, you go this times this first, right? That goes on the top. And then be careful here. You said 8. Is it 8? Do we care about the sign in front of 8? Yes, we need it to be -8. Okay, so -8. So Laura, I'm taking it that you didn't do this one for homework. It's okay. I mean, homework, this is college, so homework is for you. You either do it or you don't, but if you struggle on tests, you've got to be doing your homework, right? So can you come up with 2 numbers that multiply to be this and add up to be this? Yes? You said yes. What are they? They have to add up to be this, though. So give me some numbers that multiply to be 16. What are you thinking of? 8 and what? 2, okay. So those multiply to be 16, but do they add up to be -8? No. Okay, so these won't work. Nothing like putting you on the spot on Monday, right?
We help.
Do you want to help, Laura? You're going to pull a lifeline here?
I gotta share like the 100 point 50-50.
You can share it. Okay. Okay. All right. What do you got?
-4.
-4 and -4. Okay. Yes? These will multiply to be +16 and add up to be -8. So this part right here, I can't really teach this, I guess. I mean, I can give you like a method, you go through all the numbers, but at some point you just have to be able to get these, whether it be on a calculator or in your head. All right? I did show you last time I like to start like 1, 16, 2, 8, and just go through all the numbers, 4 and 4, and then just kind of mess with the signs until you can try and get it to work. And does it always work? Doesn't always work, right? And when it doesn't work, we say it's prime. But in this case, if we make both of those negative, we've got it. So -4, -4. Who asked about this problem? Okay, so at this point, we're going to leave the x squared here, and then inside, we leave the 2 n's alone, right? And then in the middle, what are we putting?
-4x.
-4x.
-4.
Minus 4x again, right? Okay. And now we're going to split this one right there. Remember, right after this, before that sign, split it. And you want to keep going?
Yes.
Okay, go ahead.
X.
Comes out of here.
No, x squared. Okay.
Okay.
And then we put the parentheses, and then we do x.
X comes out. Another parenthesis, right?
Another parentheses, and it's gonna be x -4.
Okay, good.
And on the other side, we go to the
You want to go x minus 4 here again? Okay.
and then you're gonna need -4.
-4. There we go. So that's what you would need to pull out in order to multiply through and get this. Now I have one more parenthesis I have to close off here to close that one
Now
off.
we have x -4,
So this is x minus 4. Okay, you want the x squared out here? Okay.
and then x -4, and
And that's this,
X minus
right? And then another x minus 4.
So, can we do like x minus 4 close parentheses power of 2?
Yes, you can leave it like this, or you can rewrite that as x minus 4, that quantity squared. Because this times itself means squared, just like x squared means x times x, right? So x minus 4 times x minus 4 means x minus 4 squared. So this or this will work.
Do I get 100 points? Because
You get, you'll get 100 points, yes.
Oh, you number is 29?
29, okay. We have a test a week from today. These tests are very frequent, but they cover less material, which I think has always been a good thing. Would you agree? 29. B. So the numbers on that look bad. Who asked? Okay. That is 27, yeah. I need to read. Yes. So this is the other one I was expecting to see some questions with. All right. So let's run through the procedure. All right. The procedure here is first GCF, right? Is there a greatest common factor there? There's nothing that you can pull out of all three terms. Okay, so we count the number of terms, 1, 2, 3, and 3 terms means AC method. Now we haven't seen one like this, but let's just go with it. Let's just see if the AC method will work. What number goes up top here? -9, and that's multiplying the 1 in front of x to the 4th times -9, and then the number here would be 8, right? Positive 8. And now you get to mess around with these numbers. So can you get two numbers to multiply to be -9 add up to be positive 8? 9 and -1. I also heard -1 and 9. Either way you write them. And we talked about this last class. It doesn't matter which way you go here. So which one do you want me to put here? 9 or -1? 9? Okay, let's go 9 here, -1 here. So these two numbers multiply to be this, add up to be this. Now, let's just follow the procedure, see what happens. If I take my first term and don't touch it, leave the middle one, and go -9 here, think about this. What are these two numbers going to be used? I mean, what is the whole purpose of these two numbers? Yeah, to make this thing split into two pieces, right? Instead of having just one. So I'm going to write 9 what here? 9x squared, right? See, that's the difference. This is like the xy problem. We had 6xy, and we need to rewrite it. We used 1 and 5. So here we have 9 and -1. We're going to write 9x squared plus 9x squared minus 1x squared. So you see the principle is the same. That middle term is just being split into 2. Questions on that? And that allows us to have the 4 terms and do the grouping. Ooh, okay, this one's going to be interesting. What happens, what can you pull out of the first two? X squared comes out of both, right? So you can pull x squared out. What would you be left with if you pulled x squared out? X squared plus 9. And now we need the same thing here, right? So we need these to match. So what we need to multiply by here through here to get back -1x squared minus 9. Minus 1. Minus 1. Any questions on that step there? We're almost done, but there is something at the end of this one that trips people up. I'm going to write x squared plus 9. That's what matches. And then what's my next piece? X squared minus 1. And a lot of people will take it to here and they'll box this up and they'll say that's their answer. And I can't give them full credit. Why can't I give them full credit for that?
Because you say simplify it to like the final form, you have to put an x squared minus 1.
What do you mean I have to?
Well, because you were saying that some people forget to put the x squared minus 1 after they.
Oh yeah, they forget here. But I'm saying, let's say this is what they write down and they box it up. Why is that still not completely right? Yes. Yeah, the x squared. Go ahead.
You just have to
So this can be factored further is what you're telling me, right? So why can't this one be factored? Because there's a plus. So when you look at this, remember there were three things we looked at last class. Well, kind of four. GCF was always the first thing we do. Then we count the terms. And we, in this class, deal with 4 terms, 3 terms, 2 terms. That's what we deal with, right? So when you get through this step and you're looking at these two, you actually have to look again and say, can you factor? This is 2 terms. The only thing we learned how to do with 2 terms was the difference of squares. So we had to have a minus between them. Here we have a plus, so we can't factor that. But this one is a minus, there's 2 terms, and this is something squared and something squared. So this actually factors further. So our next line should read x squared plus 9, and then this one should be x plus 1 times x minus 1. Now it's completely factored. So this step, if this was your answer right here, I don't know, you get 8 out of 10 points. You don't get the whole full credit because you have not completely factored it yet. Make sense? Okay, we're going to get more practice as we move on today because we're only adding one little thing to this, and we started doing it at the end of class last time. If you have any additional questions over homework, please just get with me, and you can email me, text me, call me if you're having trouble with any of these. We are going to continue. We were solving equations last class towards the end, and I told you about the zero factor property. Remember the zero factor property? It basically said that if you ever have any 2 things that multiply to be 0, one of those has to be 0. Or even if you have 3 things that multiply to be 0, one of these 3 things has to be 0. Now, did we do that one in class last time?
Yes.
We did, right? Okay. So I'm going to, yeah, because we had to rearrange the order, so I thought we did that one. Let's move on to the next one. All right. So this one right here, this problem right here still causes problems with my calculus students. They still do this problem incorrectly, and I always have to tell them to be careful on this. So does anyone want to volunteer how we would go about solving this? And I'm hoping someone's going to make the mistake, but, do you want to go for it?
We'd have to move 5x over to the other side
Move 5x to the other side. Why are we doing that?
to make it equal 0.
To make it equal 0. That is the correct way to do the problem, okay? Now, the incorrect way, all right, I hate showing mistakes because then it plants it in there. But let me show you the incorrect way of doing this. You realize, okay, they both have x here and here, and they both have a 5. So people will come through and divide by 5x on both sides. Okay, let's just see what happens if you do that. If you divide by 5x, then this side becomes 1, doesn't it? And then this side, 10 divided by 5 is 2. And what's x squared divided by x? Just a single x. So you get 2x is 1, right? And now you divide both sides by 2, and you get x is a half. Do you follow what I did there? Now, it turns out that is a correct answer, but you're missing an answer. So let me write this back up here. Doesn't 0 work? If x is 0, doesn't that work? Right? If I plug in 0 here and 0 here, is this true? Yes, right? But somehow doing it this way, we lost that answer. And the reason is because you divided by a variable. And whenever you divide by a variable, it's very dangerous. If you plug in 0 where? Yeah, for the original problem, you get 0 equals 0, which is true, right? And that's when we're trying to find solutions to equations, we're trying to find the values of x that make it true. So x equals 0 works here, right? We said that works just by looking? Yeah. But 1/2 should also work. So let me try it. If I put 10 times 1/2 squared, that should be equal to 5 times 1/2. Let's see if it is. What's 1/2 squared? 1/2 times 1/2? 1/4. So this is 10 times 1/4. Does that equal 5 times 1/2? Well, 10 times a fourth is the same as 10 over 4, right? You just multiply straight across. There's like a 1 underneath that. And over here, multiply straight across, what do you get on this side? 5 over 2. So are these the same thing? Is 10 over 4 5 over 2? Yes, it is. Same thing. So x equals a half works. So these are the two solutions. But doing it this way, you lost one of your answers. So the correct way of doing it is what has been suggested, and that is to first move everything to one side to make it equal 0. So I'm going to subtract 5x here and subtract 5x here. That way I get equal 0. Now be careful there. Your steam, you're good, right? Christian, is Christian? Christian, when I subtract 5x on the right side, what am I left with on the right side over here?
0.
Okay, now what about the left side? What's 10x squared take away 5x?
Well, is there 10x squared minus 5x?
Yeah, that's it, right? Okay, so I just want to make sure everyone's on board with that. That's another common mistake I'll see, is that people will do this subtraction, they'll somehow make this like 5x or something. You cannot subtract those. They're not like terms, right? So you have to keep them just written like that. And you want to keep going, Christian?
Yeah, I guess, but
You sound
I'm
very...
right now. Oh yeah, but
Okay, so on the left-hand side, let's just go through the factoring steps. So first step for that is what?
5x.
Pull out a 5x, right? So pull 5x out. What would you be left with in here?
You're gonna be left with 2x.
2x minus 1. Good. Everyone agree? Now we still have to write equals 0. And now, Christian, do you see there that you have two things that multiply to be 0?
Yeah.
You see the multiplications right here, right?
Okay, yeah.
So you have this thing times this thing equals 0. So now you set each one of them equal to 0. So I'm going to take 5x, set it equal to 0, and then the other one is 2x minus 1 equal to 0. Make sense? And now we solve each of those. So now we have two little linear equations to work with. How do I solve for x here? I mean, x is 0, right? Can you all just tell by looking? You could also divide both sides by 5. Because 0 divided by 5 is still 0. So on this one, what do you have to do, though? To get x by itself, add 1 to both sides, and then divide both sides by 2. And there it is, right? Didn't we have a half earlier? But see, we also have the 0. So we have our two solutions. So just remember, when we're working with these equations, we're going to want to move everything to one side, set it equal to 0, and then start factoring the left-hand side. 2x. This one right here? Okay, so at this point right here, we pulled a GCF. We pulled the greatest common factor. We saw there was a 5 in both of these and an x in both of these. So we pulled that out. And then if you distribute this back through, 5x times 2x gives you 10x squared. 5x times negative 1 gives you negative 5x. Good? Okay. All right, let's look at another one. Zoom this out just a little bit. Let's look at number 4 because it has fractions, and you all love fractions. Let's see if anyone remembers what I like to do when I see fractions in an equation. Does anyone remember? When we were doing linear equations and we had fractions, I told you I always like to
Don't you multiply it?
multiply.
By the, I don't know.
Yeah, multiply by the greatest common denominator. Okay, so look at this right here. This is an equation, right? It's an equation. And so when you have equations, whatever, you can always do one thing to one side and do the same to the other. So because I see fractions, I don't like them, I'm going to get rid of them by multiplying by the greatest common denominator, which would be? 3 would be the least common divisor of these two. You need the
Will be 9.
you need the smallest number that is a multiple of both of these. So 9, right? Like 9 goes into 9 and 3 goes into 9. So we're going to multiply both sides of the equation by 9. All right, so watch how I do this. 9 on this side times the whole thing equals 9 times the right side. Okay, why did I put parentheses over here, but I didn't put parentheses over here? Yeah, because there's two terms here, so the 9 has to distribute to each one. Here, 2x over 3 is only one term, so I just put 9 in front of it. All right, now we distribute. So this step right here, all I'm doing here is clearing fractions. Okay, that's all I'm doing, clearing fractions. So what do we get when we do that first multiplication? That 9 times x squared over 9. Let's see. Is David around? Yes, David. So what do you get here, David, when you multiply this through?
Don't you cancel the 9?
Yeah, the 9s are going to cancel, right? That's the whole idea. That's the reason we're doing it, right? So the 9s are going to cancel, and all you'll be left with there is the x squared. So you have x squared. Now keep distributing there, David. Because we've only done the first multiplication through the parenthesis, right? So what would come on the next one through? Plus 9, right? Because you're going to be doing 9 times 1. Okay. David, are we done on the left side? Yep. Okay, what about the right side, David? What do you get when you do this right here? 6x. Okay, so how's he getting that? There's kind of multiple ways of doing this. You could say 3 goes in 3 once, 3 goes into 9 3 times, and then 3 times 2 is 6. Or you can do 9 times 2 is 18, and then divide by 3. Either way, you're going to get 6, and then you still have the x. Okay. Timothy? I stopped asking how your weekends are. Sorry. It's nothing personal. Timothy, how do we go about this now? We've got the fractions gone, so what is going to be our procedure now? It's all right. That's why I'm calling on you. I'm trying to get it going.
Move the 9 to our side.
Okay, so we want to move everything to one side. We want to get a 0, right, on one side. So if I move the 9 over, I'm still not going to have 0 on one side. So why don't we just take this one to the other side? Right? If we move this to the other side, I'll have a 0 over here. Okay, let's do that. How would I get rid of 6x on this side? How do I get rid of it? Subtract it. Okay, so I'm going to subtract 6x here, subtract 6x here, right? And Timothy, we're going to keep going with you because we're going to go until your brain's feeling better. Right-hand side, when you do this, you get 0. Okay, now here, when you put all this together, what do you have?
X squared
Uh-huh. Let's go in descending order. X squared,
minus 6x
uh-huh,
plus 9.
plus 9. There you go. Right? Now that we've got it equal to 0, Timothy, you look at that, and now you start your factoring, right?
Yeah.
Okay, so do we have a GCF? Greatest common on there or no?
No.
Nope. Okay, how many terms?
3.
3, so that means
You have to use the AC.
AC. Okay, so let's do that. I'm going to go a little faster through this because at this point, the idea is that you're ready, like you know how to do this now, okay? Yes, it'll take you some time, so I'm just going to write it down and go quickly. So those are your numbers. No, negative. Oops, I messed up. This is minus, so these both have to be minus. Yeah, that was my mistake. Okay, so trusting that you could do the rest, I'm going to say dot, dot, dot. Okay, that means that there's more work that I'm not showing here. All right, this will become x minus 3 times x minus 3 after you do your grouping here, right? All right. Now, Timothy, we have two things that multiply, right, to be 0. Right? They multiply to be 0, so we're just going to set each one to 0. And they're the same thing, aren't they? So really the only thing I have to do is just set x minus 3 equal to 0. Add 3 to both sides, and we get just a single solution. Just one answer. X is 3. So we're falling back on what we learned last class in terms of factoring, but now we're incorporating it within a problem where we're solving equations. Any questions on that one? Sure? All right, why don't you have a look at these? Tell me if any of these look like something you want me to do. Here. Which of these looks... Well, let's just talk through them, okay? Let's see if we can't figure out just by verbally talking through what we would do for each one. Okay, so let's start... Oh, I went too far. Okay, look at number 11. Number 11, how would we proceed with that one? That one's a little tricky. You like fractions or do you not like fractions? You do not. Okay, so how would you get rid of the fractions here?
So we still multiply?
Multiply both sides by what?
2.
2. By 2. So let's see if we can do this in our heads, or not kind of our heads. What would this times 2 be?
1.
Just be 1, so you just have x squared there, wouldn't you? Okay, and then what would this one times 2 be? Don't forget you have to do them both, right? Minus 64. And then equals, and then you do the right side times 2, and 0 times 2 would give you that. So now at this point, we have it equal to 0, right? X squared minus 64 equals 0. And now you look at the left-hand side, no GCF, right? You count the terms. How many? 2. So it better be a difference of squares. Is it?
Yes.
It is. X plus 8 times x minus 8. Then you set each of those to 0. What about this one? Move 49 over, right? You move 49 over, you get that. It's equal to 0 now, right? GCF? I don't think so. There's no GCF there. Count the terms. 2. So if it's going to factor, it's got to be a difference of squares. Is that a difference of squares?
Yes.
Yes. That's 4t plus 7, 4t minus 7. Again, this is going back on last class. All right? How about this one? No fractions to worry about, right?
You move the 6 and then set it up in descending order.
Yeah, you can move the 6 over and then putting it in descending order and using your AC method, because there's 3 terms. How about this one? Oh, go ahead. What?
But in that case, when we put it in descending order,
Do you want me to do that?
minus 4x squared is gonna be in the middle, right?
The minus 4x squared will be first, and then I'll have plus 11x. And then I'll have minus 6 since we brought it over to the right-hand side.
Yeah, it's the power that.
Yeah.
Descending order, right?
Yeah. So at this point, you can use your AC method. All right, this one, just AC method right off the bat, right?
Yeah.
We have equals 0 already, 3 terms, no GCF, go to AC. That would be ugly, wouldn't it? Ooh, that'd be ugly. Those numbers are kind of big, aren't they? Okay. I'm moving on. We may come back and do one of these. This one, bring everything over to one side, equals 0, and then AC method again, because I'll have 3 terms. This one, it's already there, right? So AC method on that one. This one, as long as there's not a GCF, that would be AC method. But I think there is a GCF on that one. What's a common, well, wait, hold on. I thought 3, but no. Right? 3 doesn't go in here. Yeah, so, yeah, big numbers. We might do one of these. That one, oh, okay, what about this one? Equals 0, but there is a GCF here. What's our GCF for this one? 2? and x. We might do that one. Or this one. This one looks pretty bad. Yeah, let's do 18. So for 18, we have 30x cubed minus 2x squared minus 4x equals 0. All right, Nivini? No Nivini? 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 No Nivini? Brianna? P?
Yes.
Yes?
So you find the GCF.
Find GCF first, and 2x. Okay, so when I pull 2x, big parentheses here for plenty of space, right? What goes in there? 15x squared
minus x
minus just x
minus 2.
minus 2. Good, so we've pulled 2 from each of these, right? And we pulled an x out of each of those. Everyone agree with that? And then equals 0. How do we proceed with that then?
So then we would factor the inside, so we would use the AC.
AC method, since there's 3 terms. Okay, let's get that thing set up over here. What are our numbers then?
15 times 2, so -30.
Negative 30. Everyone follow that? Negative 30 is coming from this times this?
And then -1.
Negative 1. Okay. 2 numbers that multiply to be negative 30 add up to be negative 1. 5 and 6. Close. I'll just put them here. Which one of those is minus?
Minus
Minus 6.
6.
Good. So these will multiply to be negative 30, add up to be negative 1. Yes, sir? We're working on this because we pulled the 2x out. So we're working here, right? We're doing AC method. So we're doing 15 times negative 2. That gave us our negative 30. All right, now we break this down. All right. 15x squared. We're using these numbers now. Plus 5x minus 6x minus 2 equals 0. So all we've done is rewritten that middle term using those 2 pieces. And that allows us to bring in the grouping. You keep going?
Not really.
Not really? Okay. You ready to pass the torch to Alyssa?
Yeah. So you bring the 2x down.
Okay, 2x is going to come down. I should have equals in front of all these, but, well, no, because it's an equation. Sorry, I thought we were, lost myself. We have an equals here, so we just go line to line. Okay, keep the equal there. 2x.
And then let's take 5 out.
Yeah, we can take a 5, anything more?
Oh, an x.
An x, right? So we're going to do 5x comes out. Then what would go in there, Alyssa?
So that would be 3.
3 for the 15 and an x, right? Because we need an x squared. So x, and then what about right here? We have x already? Plus 1.
Yeah.
Okay, yeah, good. And that's one of those ones that I said a lot of people have trouble with, is that since you pulled this whole thing out, people will forget you need something there. But remember, with the distribution, you have to be able to create the 2 terms. So plus 1 there. Now over here, let's try and see if we can't get that to match. 3x plus 1 here. Okay, so what would have to be put out here to multiply through to give you back this? You're trying to get 3x to become negative 6x and 1 to become negative 2. Negative 2. Negative 2. And then we'll close the parenthesis and then put equals 0. One of the things about these parentheses, whenever you have a mathematical statement, you should have the same number of parentheses facing one direction as you do the other direction. So let's see. How many do I have? I have 1, 2, I have 3 facing that way, right? And how many do I have facing the other way? 1, 2, 3. You see that? You should have equal number. You shouldn't have like 3 facing one way and 2 the other. Yeah? Does that make any sense or no?
Well, no, I don't know. I just did it a little differently than that way.
All right, we're not done. Alyssa said she wanted to take this the whole way. So what would be our next line? The 2x? Okay, and then 3x plus 1, good.
5x minus 2.
Perfect. There we go. And then equals 0, right? So that's just taking this whole piece in here. That's our grouping. We've done that already, our AC method with grouping and done all that. We know this becomes 3x plus 1, then 5x minus 2. We just slap the 2x out in front. So Alyssa, how many things do we have multiplying together here to be 0? 3 things, right? So that means we have to set 3 things equal to 0, right? We have to 2x to 0, 3x plus 1 to 0, and 5x minus 2 to 0. All right, so now we're using that 0 factor property, setting each of our factors equal to 0. You're almost there.
So the first one is 0.
First one is 0. You can just divide both sides by 2 and you're done. Second one, minus 1 over 3. Right, so you subtract 1, then divide by 3, and then this one you'll add 2 and then divide by 5. So 2 over 5. Those are your 3 solutions to this equation.
So when you were saying where you put the 5x and the negative 6x, so you put the negative 6 because there was a negative 2 on that side?
Wait, where?
See
What?
where the negative 6x goes?
Right here?
Yeah.
Why did I put this here?
Yeah.
Well, our 2 numbers that we came up with were 5 and negative 6.
Okay.
So we had to rewrite this, right? It's rewriting this with those 2 numbers. So we put 5x here and minus 6x here. That's how we split this up off of our cross.
So I guess it doesn't matter which one.
Well, you could put minus 6 and plus 5x. Did you do it the other way?
Yeah,
You should get the same answer. If you did yours, you should have had 15x squared minus 6x plus 5x minus 2, right? That's what you had? Did you write it this way?
yeah.
Okay, we should get the same answer. You split it. What did you pull out of the first one?
The 3x,
3x, good. And then that should be left with,
5x minus 2.
okay, and that means this one has to be 5x minus 2. And so what do you pull out of this? Well, it's already the same thing, isn't it? So you have to put plus 1 there.
Okay, so that's right. That's it.
So your next line should be 2x, that was out front, then the 5x minus 2, and then the 3x plus 1. And that's the same as this. Yeah, anytime this matches exactly to what you want it to be, you have to still have a number here.
Yeah.
So you put plus 1. All right. That was a good problem. There's a lot in there, right? All right, I think you're ready to go and do some of that for homework. All right, we need to talk about radicals now. Does everyone have a calculator with them? Okay. So when we see here this expression, square root of 12. Well, let's start with this. What is square root of 4? 2. So it's 2 because this symbol, this little symbol here, is like an operation. It's asking you a question. It's saying, hey, look at the number here. Can you come up with the number that when you square it, you would get 4? That's what this is basically saying. What number squared is 4? What number squared is 4? And of course, 2 works, right? Okay, so when we see square root of 12, the problem is 12 is not a perfect square. Like, no one's going to be able to sit here and just come up with the number, right? So on your calculator, put in the square root of 12 and see what you get. And you're going to get a decimal, and so I'm going to put a little squiggly equals for approximately. What do we get on that? 3 point what?
4.6.
4.6, somewhere around there? Now, does that answer, does it make sense?
How do we put it?
Okay, good. So that's why I'm asking you to do it. Let me see. So for this, see that x squared? You're going to hit the green button first,
Green?
and then that will bring the green above it, you see?
Okay.
Now put 12 and hit enter.
So mine brings it out as 2 and then square root.
Okay, so that's, yeah. So what did yours say, 2 root 3? Okay, so yours said 3.46 because you're using a different calculator, which is okay, all right? So what was the one, what did your calculator say? 2 square root 3. All right, so let's talk about the two different answers off of the two different calculators. This calculator is kind of a basic calculator, but it does what most calculators are going to do here, and that is give you the decimal answer. This is saying that if you take this number and you multiply it times itself, 3.46 times 3.46, you should be really close to 12. This did not do that, right? This did something completely different. So notice the squiggly equals here. Means approximately. So would you do this on your calculator? Go ahead and do 3.46 times 3.46. Tell me what you get.
11.9716.
Okay, so you get 11.9716. See, what's happened here is we've had to round a little bit. So this is an approximate answer. It doesn't give you the exact square root of 12. This answer is known as the exact answer. There is no rounding here, but it still has a root, doesn't it? So it's kind of like if I write, I'm sorry, if I write 1/3, that's the same as 0.333, if you do this on your calculator, repeating forever. This is a decimal, this is the exact answer. We can't write 333 forever, so at some point we would stop and round, right? So that's what this is. This is a rounding approximation. This is an exact answer. In this class, I don't care about this, okay? I don't care about you being able to do this. So your calculator is going to give you this answer, but that's not what I want. I want this one, all right? And so the way you do it on your calculator is when you, these are for the people who are getting this. Once you get the square root up there, put in there 12.0 and then hit enter. And that'll give you your decimal approximation. All right? So we are not going to go through this simplifying radicals. And the reason why is because of what we're going to be doing with this. At the end of the day, we're going to want a decimal. So I'm not going to be going through the procedure for simplifying. Just as long as you can get it on your calculator and get the approximate, we're good. So that means in your homework, your answers are going to look different than the answers in the solutions. Right? So the answer to this one, we're going to say is 3.46 approximately. What's the square root of 72? What is it? 8.48. All right? And it is approximately. I shouldn't be putting equals there, but that's what I'm. Okay, let's try this one. Now this is a different looking expression. Do y'all see the plus and minus right here? What this means is they want you to do this two different ways. First, let's look at the plus, and then we'll look at the minus. If we do it as a plus, you're going to have to do 10 plus root 16 over 4, and if you do it as a minus, you do 10 minus root 16 over 4. So on your calculator, you need to do this first. Type all of this in first, and then hit the enter key. I'm going to get my calculator out. So somebody want to volunteer? How about Miranda? I'll get you off the list here. What did you get for just the top 10 plus root 16? 14? Okay, right? And then over 4, right? So, and then when you do that, what are you getting on your calculator? 3.5. So did it give it to you as 3.5 or did it give it to you as a fraction? It did? Okay. So 3.5 here. All right, Miranda, what's the difference if you do it this way? 10 minus root 16 over 4. So on the top, when you do that, you should get 6 over 4, and that should give you 1.5. So there are two different answers that we got here, 3.5 and 1.5. We good? Do the next one. This is two different answers here. So plus and a minus. We first do 15 plus root 45, then divide by 6, then we do 15 minus root 45 and divide by 6. Brianna, Garza, how you doing? Good, good. Your calculator, yeah, that one's going to work. So can you tell me just what 15 plus root 45 was on your calculator? So just doing the top right now. Yeah. Let me see. I'm going to watch you type it so I can. 15 plus, and now the square root. 45. Put the 0.0 right after. Oh, it did it. Okay. 21 point. Let's say 21.71 off that. 21.71 over 6. Okay, so now divide that by 6.
3.62.
Good. All right. Y'all getting this? 3.62 for this top one? All right. Now try this one on your calculator. Make sure you can get that one. Oy, I keep messing this up. What are y'all getting here? 1.38. Okay, so at home when you start doing these, just practice. That's all this is. Remember, your answer's not going to look like the back, so we might need to double check your homework answers. Or you should be able to just take the answer and just plug it in, type it, and get the same decimal. Luke?
So what do you want us to cut off as far as rounding?
Okay, rounding. Let's just say 2 decimal places. All right, and if we're off a little bit, it's no big deal, right? We're not. I think I probably said this. We're not trying to land a man on the moon here, right? We're just making sure we can do the correct. You know, if we're going to use our calculators, make sure we can use the correct keystrokes. Make sure our order is correct. If you type, there's a danger. There is a way that you can type this in incorrectly if you try and do it all at one time. Like if you just type in 15 minus root 45 divided by 6, all at one time, you're going to get the wrong answer. You have to do the whole numerator first, then divide by 6. So that's what I want you to be practicing. You don't want to make those mistakes at home.
So for the bottom one, I got 1.18.
You got 1.18?
Yeah.
Okay.
1.118.
1.118? Let me see.
I guess,
There could be some, let's see.
well, no, it's because I'm probably putting it in my calculator, like, because I don't put the 15 plus 45 or the 15 minus 5, like, as one. I do the square root, and then I'll add that to the 15. But for the minus one, I didn't know how to subtract. Like, let me put it like this.
Yeah, I know what you're
You know
saying.
what I mean? So, it's like, I guess, like, if I put it in parentheses, right?
15.
Minus square root.
Yeah. That's why these calculators, we try and have everyone with the same calculator because these are all going to do them a little different. I can show it to you after class. You have a minute? Yeah. Okay. All right. Now, try the next one. Try number 5. Paris, do you have a calculator? Yeah?
Yes, sir.
Did you do number 5?
Not yet, but I'm.
Okay.
Is domain here?
Domain error. Paris, what does yours say?